All right, so this video is going to go over the Chapter 9 Inheritance quiz number 3, practice quiz number 3. So it says use the declarations below for questions 1 through 3. So we got a solid abstract object. So abstract objects can have full methods like this that are implemented, or they can have abstract methods. If there's an abstract method in there, the class itself has to be abstract. So it looks like the solid constructor takes a name and then it can get name, and the volume will be implemented at the sphere or rectangular prism level. Okay. So you got your sphere. Now wait a second. Is name. My name is private, so it can only be accessed through the public method getName. Okay. Sphere extends solid. Sphere has a myRadius that is private, so it can only be accessed in the sphere class. The constructor takes the name and the radius. Name is supered in from the solid. And then we have the volume method, which must be implemented at the sphere level because it was abstract at the solid level. Okay, or if it's not implemented here, then this would also have to be abstract, an abstract method. But this is how it's done right here, so this is fine. So volume of a sphere is this calculation right here, basically. Okay. You could use, math.pow myRadius to the third power or whatever if you want to. But I just did myRadius times myRadius times myRadius. Okay, then we have a rectangular prism. It has 3 private variables, my length, my width, my height. They can only be accessed in the rectangular prism. Rectangular prism inherits from solids, so you'd have the name and then the length, width, and height. The name would be supered in, and the volume also has to be implemented here because it's abstract at the solid level. Okay, so the volume of a rectangular prism is length times width times height. So a program that tests these classes has the following declarations of assignments. You got your solid S1, 2, 3, and 4 objects. So how many of the above lines of code are incorrect? There's one clear answer here. One of the big things you have to know is you cannot create an instance. You can't create an object or an instance of an abstract class. Solid is abstract, so you can't create an object of it. So that's an error right there. S1 equals a new solid. But you can create an S2 as a new sphere because its sphere is not abstract. And S3 is a new rectangular prism. That's fine. And you can make a null S4 if you want. So the answer to 1 is A. 2, which is false. If a program has several objects declared as type solid, the decision about which volume method to call will be resolved at runtime. That's true. That's your polymorphism and overriding the get volume, or what is it called? Is it just called volume? Can't remember. Yeah, I mean, at runtime, it's going to go, well, which one is it? Is it a sphere or is it, a rectangular prism or whatever, and it will call that at runtime. So A is true. B, if the solid class were modified to provide a default implementation for the volume, if the solid were to default, it would no longer need to be abstract. Yeah, true. If you implement it, it's not abstract. So B is true. C, if the sphere and rectangular prism classes failed to provide an implementation for the volume method, they would need to be declared as exactly. Yeah. If you don't implement the method, it must be an abstract class, meaning the class needs to be abstract, and those methods would need to be, the volume method would need to be abstract there as well. That's absolutely true. D, the fact that there is no reasonable default implementation for the volume method in the solid class suggests that it should be, it should be abstract. There's no, because again, you have all the different ways to calculate volume for all the different types of, spheres or prisms or whatever you're creating. You wouldn't want to do that at the solid level. And solid just seems like it would be abstract just in general, because you want, what object is solid? What does that represent? So it's kind of like an idea of something, so it should be abstract. You don't want to create an object of it. So E, since solid is abstract and its subclasses are not, polymorphism no longer applies when these classes are. Polymorphism does apply. It doesn't just go away. So that hopefully you guys are figuring out polymorphism. It can take, you've got your, objects that can take many forms, I guess you'd say, with poly meaning many. 3, here's a program that prints the volume of, so your answer for 2 is E, sorry. Here's a program that prints the volume of solid. So a solid main, it calls print volume. So main gets called, you have a sol solid, a sphere solid, rec solid. So you flip a coin randomly, it returns 1 or 0. If it's 0, then the sol is the sphere. And sphere would have the name sphere and 4, or if it's, I guess the flip coin is 1, it'd be a box 3, 6, so that's the length, width, and height. Print the sol. So it'd go up here, print the solid. The solid object would be passed in s.volume. It would call whatever volume you want it to, which is a true statement about the program. It will output the volume of the sphere box. Yeah, absolutely, because you're assigning your sol, which isn't assigned here yet. It's being assigned to either a sphere or a rectangle, and a sphere or a rectangular prism is a solid, so those get set properly. And then at runtime, S would call the volume of the sphere, the volume method in sphere, or the volume method in rectangular prism. So that would work fine. So yeah, your answer is A. B, it will output the volume of the default. No. C, no. Compile time error because there's no implementation code for the volume. No, because again, sol is being assigned to a sphere or rectangle. E, a runtime error will occur because of parameter mismatch. No. So yeah, your answer is A. 4, which statements about interfaces is true? An interface contains only public abstract methods and public final. That's true. Okay, you can go back and watch the video I created about interfaces and abstract classes, and that's one of the things you must know. Interfaces can only have abstract methods and public static final fields. 2, if a class implements an interface and then fails to implement any method in that interface. Yeah, Yeah, it must be abstract. So again, if it's abstract at the higher level, it needs to either be implemented at the lower level, or that lower level also has to be abstract. Okay, that's one of the fundamental things that you have to memorize in this chapter. 3, while a class may implement just one interface, it may extend more than one class. No, you can only extend one class. You can only extend from the superclass above. You can have as many classes and hierarchies as you need, but they don't jump multiple, they don't, you can't extend them more than one time, so it's only used once. So yeah, your answer is 1 and 2 are correct and 3 is wrong, so that is B. 5. So a programmer has the task to maintain a database of students of a large university. There are 2 types of students, undergrads and graduate students. About a third of the graduate students are doctoral candidates. All the students have the same personal information stored. Okay, for each GPA for each student's GPA is computed, but differently for undergrad and grad students. The doctoral candidates have information about their dissertations. Okay, so the best way to start this one, this is really wordy, so it's probably best to do a diagram. So let's do this. So at the top level, you got student. Then you're going to have an undergrad. Ugh, that's such bad writing. You have a grad student. And there's a specific type of grad student called a doc student. And that's really what your hierarchy looks like. Doc. Again, this is super hard to write, so I apologize, it looks bad. Ugh, it's just awful. Let's make this a little bit better. Doc. Doc student. All right, so the programmer will write a program to handle all the student information, which defines the best design in terms of programmer efficiency and code reusability. All right, so if you make this an interface, if you go back to question 4, you know that interfaces can only have public abstract methods and public static final fields. Well, aren't there a bunch of things that all the students have in common? So we want to be able to use some of that stuff. Personal information stored, name, address, phone number, student information like courses and grades. Okay, so that's the kind of stuff that you would want to implement in student. You wouldn't want to have an interface there. Okay, so A doesn't work. Okay, so cross that off. You will not know that if you don't memorize what an interface is, because if you did it like this, you wouldn't have any inheritance. That's the whole point, is writing the basic information that's going to be used at all levels at the very top, so you don't have to write them over again at the lower levels. Okay. Let's see here. Let's jump to E. Look at this, public abstract graduate student. What's something you know about abstract classes? Well, they can't be instantiated or created. If you have an abstract graduate student, can you create a graduate object? No. So E's not good. Okay. Let's see. D, the biggest example of why D doesn't work. Does a doctor student extend student? No, a doctor student extends a graduate student. So it's not good. Let's see here. Public class student. Okay, B and C are your choices so far. What's the difference? Well, you know, a lot of this is getting down to, okay, is a student abstract? Let's see here. Extend student. Extend student. Public class graduate. Extend student. So B and C are the exact same except for those, and so you would want to make certain things abstract because each student's grade GPA is computed but differently for undergrad. If this is an abstract, then you have to implement the way you grade at the student level, and that would screw stuff up because these guys are graded different than these guys, and these guys are graded different. So you want to make sure that's abstract. So B is your answer. That won't work. At the same time, there is an undergrad, a grad student, and a doctor student, but there's not just a student. You have to fall under one of these categories. And so making this abstract would prevent the user from creating an object of student. So you don't want to be able to create objects of student. Okay. So I'm going to close that. So your answer for 5 is B. All right. So let's see here. Short answer. Considered a busy warehouse with items coming and going. The following abstract class represents an inventory item in the warehouse. So inventory item is abstract, so this would never be, an object of it would never be created. It's got private variables, ID, a date entry, and a base price. Its constructor passes in the entry date and the price. So ID is equal to make ID. And I guess make ID is down here and the implementation is not shown. So some sort of ID number would come with this. You get the date and you get the price. So its public methods can get the date. Its public method can get the base price. And getting the price, so you can get the base price, but getting the price of this is abstract. So it needs to be implemented at a different level of our... at the lower level. I don't know what the next class looks like. So we got, oh, okay, cool. So you got different, so like imagine working at a grocery store, okay? You got all of your inventory, but the big thing to think about is non-perishable versus perishable. So this would be like all your canned goods and boxed goods. They're not going to go bad. But you do got perishable goods, which can spoil, like your fruits and vegetables and salads and all that kind of stuff. So the prices, the way that you'd calculate prices would be different, because think about it, non-perishable, it can sit on the shelf for days, weeks, months, and the price is what it is. It's not going to want to change. Perishable items, the grocery store managers should be watching them. If items aren't selling at the current price and they're going to go bad, then it's better to get some money than no money, because you get no money for spoiled goods. You just got to throw them away. So, if the expiration date is getting close, then you put on a 50% sale, and, because free markets work and prices entice people to make decisions, people buy more of it and the inventory goes away, and you still get to make some money on it. So each inventory item has a unique ID, a date of entry into the warehouse, and a base price, which may possibly be discounted. Dates are represented with the date class not shown, which implements the comparable interface. Larger date objects are later dates. Some inventory items are perishable and some are not, giving the following class hierarchy. Items that are not perishable have no discounts. The non-perishable class is implemented as follows. So, to get the price, we get the base price. We super that in. Okay, it is implemented here. It's abstract at the inventory level, but it's implemented at the non-perishable level. So we just get the base price. There's no discount based on the date of the can on the shelf or whatever. So we super in the entry and the price, okay? This is all pretty easy. Perishable items have an expiration date. Items already past their expiration date when they enter the warehouse are discounted by 90%. Otherwise, no discount applies. Write the complete declaration. Okay, so A. So you've got your private expiration. So you've got your entry date and you got your expiration date. Private to perishable. So perishable is the only class that can look at the expiration date. You got a discount. So perishable would super in the entry and the price, and then it would pass in the expiration date and assign it to expiration. Should be easy by now. All you're doing is you're supering in the variables from inventory item that you can use that have already been written, and you add what's specific to perishable, which is the expiration date, and then you've got to implement the get price. So this is kind of difficult with dates, but if the expiration dot compare to the super dot get entry date, we get the entry date when we compare them. If it's less than 0, then you do the base price times the discount, else you just do, so this would be that, it's expired, do the discount, else don't do the discount, just get the base price, okay? This is the hardest line of code in here right there, but we've been through comparables, so. Consider following warehouse. So B, the warehouse class, which stores the list of items in the warehouse inventory. So we're going to have an array list of all of our inventory items. So we're going to get our items, which is going to return an inventory item from array list. The low, and we pass in the low and the high price. The method get items behaves as described in the commitment. Implement get items. Okay. So in here we've got our list. It's a list of inventory items, and we can just loop through it. For each one, we can get the price if it's greater than the low price and it's less than the high price. Then we add it to our inventory list or inventory item list, and then we return it. So right here it says returns an array list of all the items whose price is between the low price and the high price inclusive. So that would give us, that's our list. If it's greater than or less than, then we add it to our list. So yeah, it's a little bit more difficult. This one, it seems like a little bit more difficult than the other examples I've given, but not too bad. Spend some time studying that. Get brushed up on your array list stuff. Don't forget that. So anyway, this video's done.